All right, so here we go. We're going to be first talking about order of operations. And let me know, can you hear me? Can everyone hear me? Can anyone hear me?
Yeah. Yes, I can hear you.
Okay, good. Sometimes it switches the mic off when I switch onto webcam, and then you guys can't hear me, so I just wanted to make sure. So the first thing we're going to talk about is order of operations. And hopefully you went and you watched the Ed puzzle I put together. But if you didn't, it's okay. But you've probably seen it in the past. Does anyone remember what order of operations are? Like if you think of order of operations, a little acronym should come to mind.
Isn't that like with the parentheses and then like the exponents and stuff like that?
Exactly. That's exactly what it is. You probably have heard it called PEMDAS, right?
Yes. Yeah.
I myself like to think of it as GEMDAS instead of PEMDAS. And the reason is P stands for parentheses, right? But it's also really any grouping that's going to come first. It's not just parentheses. So it could be parentheses, brackets, absolute values. You know how absolute values are in the straight lines? So that's absolute value when you have like something in between the straight lines, and it would be the positive. Those are the things you're going to want to deal with first. And when you're dealing with them, we're talking about you're going to the innermost the innermost grouping to the outermost, and you're dealing with what's inside the grouping, not outside the grouping. So if I have something like 3 times 4 minus 5 minus 2 squared, when I look at that, I'm going to deal with what's in here first, right? So I have 4 minus 5 is minus 1, minus 2 is negative 3, right? Did I get that right? 4 minus 5 is minus 1, minus 2 is negative 3. So I would have 3 times negative 3 squared. When I look at what the next step is, I can't do anything with this 3 times negative 3 yet, right? Because it's not part of the grouping. It's not part of what's in the parentheses. The P only refers to what's inside that grouping, right? So we would move on to E now, and we would look at our exponent, and we go, well, negative 3 times negative 3 is 9. And so I would have 3 times 9, and then we would do our multiplication, and we would have 27. Now, the P works great. The E is exponent. Makes sense, right? Anything with an exponent, anything raised to a power, right, comes next. Here's where you guys screw up. Not necessarily you guys, but students in general mess up with the multiplication and division and the addition and the subtraction. And the reason that is because of the way it's written. It says MD, and it makes you think that multiplication comes before division or addition comes before subtraction. And it doesn't. Multiplication and division are equal, right? They're equal. And you do whichever comes first from left to right. Addition works the same way. Addition and subtraction are the same thing. They're equal to each other. They come after multiplication and division, but they are equal to each other. So you do left to right the same, right? Whatever comes first. So those are big mistakes that people make all the time when they're dealing with order of operations, because we have this great acronym, PEMDAS, that's supposed to tell us the order in which they lie, but people don't realize that multiplication and division are the same. Parentheses is all groupings. Addition and subtraction are the same. So if I had a problem, like say 4 times 2 plus 3 times 4 minus 1 divided by, we'll say 3, right? I was trying to do the numbers in my head to make sure I get an even deal. The first thing we're going to deal with is what's in our grouping, which is 4 minus 1. So I like to rewrite my problems, but you don't have to. 4 minus 1 is just 3 divided by 3, right? Next, I don't have any exponents. I have nothing left to do within this grouping. I just left it in the parentheses so that you'd realize that it's multiplication, right? So I don't have anything left to do inside a grouping. I don't have any exponents. So now I'm going to look at multiplication and division, and I'm going to do them in order of which they appear going from left to right. So I have 4 times 2. Well, that's just 8. Plus 3. Well, I can't do anything with plus 3, but this is technically 3 times 3, right? And 3 times 3 is 9. And I've still got that divided by 3. Now, what happens next? I've got, do I have 8 plus 9 divided by 3, or do I have 9 divided by 3?
9 divided by 3.
Exactly. We're going to do that division first. So we would have 8 plus 3, which would just be 11. Okay? And I know you guys have worked with this stuff before, but I just wanted to make sure those things are clear. If you guys watch the Ed Puzzles, I kind of put in little notes clarifying those points. But I wanted to make sure you absolutely understood that before going on, because it's one of the big errors that people make when they're dealing with order of operations. The other thing I wanted to talk to you about is real numbers, because you guys took Algebra 1, and that's what we were dealing with in Algebra 1. It's exclusively real numbers and the real number system, right? And our symbol for it is this little R with 2 lines, capital R with 2 lines. And the real number system is made up of a bunch of different sets of numbers that all are part of the real number system. And then the real number system is part of a larger system called the complex numbers. And that brings in imaginary numbers. So the difference between Algebra 1 and Algebra 2 is we start working within the complex number system. Now, I'm not going to go over complex numbers with you today, but we're going to start using them in the future. But I want to make sure that you have nailed down what makes up the real number system before we move on. This is stuff you've probably seen before. I'm just going to go through it with some depth so that you understand where it's all coming from. Once I get through this, I'll have a little talk with you about how I might put this in the quiz or word it in the quiz on Tuesday so that you have an advance warning of that. But right now we're just going to start with what the real number system is. And the real number system starts with what we call the natural number. Sometimes you'll see it like an N with the extra line. Sometimes it'll just be a capital N. But what we're looking at are the natural numbers. And the natural numbers are just the counting numbers, the set of counting numbers starting with 1. So they're 1, 2, 3, 4, forever and ever and ever, right? Till infinity, because you can never run out of natural numbers. They're infinite, right? We can start with 1, but we can always add 1 more to the next. And we can do that forever and ever until we die, and then somebody else takes over, and we'll never run out of numbers because we can always add 1 more. Then we've got what we call the whole numbers. The whole numbers are also your counting numbers. And the only difference between the whole numbers And the natural numbers is we start the count at 0 instead of 1, right? They still go on and on forever and ever. They're still both infinite. The difference is natural numbers don't have 0, whole numbers do. So when you think about that, you could see that all of the natural numbers fit within the whole numbers, right? It's just this one doesn't have 0. They're your whole counting numbers. So even though this is infinite and this is infinite, this infinity right here is slightly smaller than the infinity below it, right? Even though they both go on forever and they're never-ending numbers, we'll never run out of them, this one kind of has one more, right? It has 0. And keep in mind, this fits into this. The next one we call Z. It's for integers. I don't know why we use Z other than the fact that I is already taken. We use it for the irrational numbers, which we'll talk about in a little bit. So I'm wondering if maybe it's something that carried over from the Greeks, because that's where we name all our number stuff anyways. The Greeks came up with everything. What I showed you before, the natural numbers are part of the whole numbers, right? They fit in. Well, both of these are going to fit into the integers, because the integers are your counting numbers, but they also include the negatives, right? So they'll go from negative infinity all the way up to positive infinity, but they're still just our whole counting numbers forever and ever and ever in both directions, right? These only move to the right on a number line. These only move to the right on a number line, but these move to the right and left of 0 on a number line. But this fits into this, and both of these fit into here, right? Our last one for this set of sets is Q. We call our rational numbers Q. One, because we use R for real numbers, and Q stands for quotient, which is division. If you have a problem in division, right, your answer is always going to be the quotient. And it helps it make sense a little bit, because our rational numbers is any number that can be written in the form of a fraction. So it's going to include all of our whole numbers, because we can write all of our whole numbers over 1, right? But it's also going to include everything between those whole numbers, right? All of the fractions between those whole numbers, negative and positive. So I could have like -4/2, which is ultimately -2 if I reduced that fraction, -1/2, 0, 1, 4/3, 7/3, right? Anything written in the form of a fraction forever and ever. So it's got all of your whole numbers, every single whole number, plus all of those numbers that fit in between, those fractions that fit in between. So if we're looking at it in terms of a set, let me put this up here. Say I have our smallest one, right? Our natural numbers, right? And they all fit in this circle. They're starting with 1, going on forever and ever, right? Around that, we would have our whole numbers, right? They can include all of our natural numbers plus 0. Around that, we would have our integers, right? The integers are all the positive and negative numbers, but they also include our whole numbers and our natural numbers, right? All of those are included in that same set. And then around here, I feel like I could draw a face in this. We have our rational numbers, and the rational numbers include the integers, the whole numbers, and the natural numbers, right? And if I draw a big old box around that, we can call this box the real numbers, right? The real numbers also contains something called I, our irrational numbers. I consists of things like pi, right? We know kind of where it goes because it's 3.14159, and that decimal keeps getting bigger and bigger and bigger, right? But it never stops. But we can tell you that it's between 3 and 4. We can even narrow it down to being between 3 and 3.5, or it's between 3 and 3.25. We can keep getting closer and closer and closer to it, but we can never narrow it down to a certain spot. And so things like that can't be written in a fractional form, or like the square root of 2, if it's same kind of thing, the square root of 5. They're these numbers that never have an end, right? So they're just these decimals that keep getting bigger and bigger and bigger, and you can never quite nail it down, but you have a good idea of where it kind of lies, right? So if you made a number line and you made your parameters big enough, you can kind of place it in between a couple of fractions, right? Like with pi, I could make a number line that was like 2, 3, 4, and I know that it's going to lie somewhere in here, right? I can go, okay, this is pi, but it doesn't really land there, right? We just kind of have a general idea of where it would be, right? And those would be our irrational numbers. Now, all of these fit into a bigger system. And that system is called the complex number system. And we're not going to talk about complex numbers today. I just want you to understand that the real numbers are part of a system as well, right? So one way to look at it, you got your natural numbers, right? They go in this direction forever and ever, but they start with 1, right? So it's the smallest set. Even though it's not by any definition small because it's infinite, it's still the smallest one because it starts at 1. Then you have your whole numbers. Well, that's a little bit longer, right? Because it starts the count at 0. Then you have your integers, right? Still part of the same set, but it goes in both directions starting at 0. And then you have your rational numbers. Well, it's the biggest one, right? Because it includes all of those fractions as well, right? In both directions starting at 0. Does that make some sense? Like how to kind of get a grip on how the systems work together? So if I were to ask you on a quiz, are the whole numbers part of the real number system? What would you answer? It would be a yes or no question, right? So would you answer yes or no? Exactly. And the rational numbers, if I said, hey, are the rational numbers part of the real number system? You would also say yes. What if I said, are the irrational numbers part of the real number system? What would you say to that? Yes or no?
No.
Actually, it would be yes, because if you look in this box right here, I is still in the box that contains all the rational numbers, right? I mean, all the different number sets. It's just separate from these groups because it doesn't fit into them. But it's still the real numbers. They're still real numbers. They're just irrational. Does that make some sense? When we move over here into complex numbers, these numbers won't be part of the real number system, but the real number system is still part of them. When we move into the imaginary stuff, and don't let the term complex numbers fool you. It's a terrible name because it makes it seem like it's difficult, but really it's not difficult. It's just a couple of rules you have to apply. Not that you have to worry about those yet, but So keep in mind, kind of get an overview. When I give you the quiz, feel free to bust out your notes on Tuesday if you guys wrote this down. I'm going to stop the video portion of this right now because I don't see any reason to keep us recording now that the lesson portion is over.